Hey guys, and welcome back to another episode of Physics in 5. I'm sorry it's been so long since I've last put out a video. I've just been really busy trying to get the website sorted and in other things that I do in my life. But I am back and we're carrying on with our energy series, and today we're looking at kinetic energy, specifically because there are a variety of different types of kinetic energy. We're looking at translational kinetic energy, which literally means things moving in straight lines. The other types are vibrational and rotational, and we'll probably get to those later down the line. But right now, translational kinetic energy. Yeah, so let's get going. Okay, so what is kinetic energy? It is the energy an object has by being in motion. Now, if an object is stationary, then it has zero kinetic energy. What we've got on the board here is a sort of smallish diagram of some mass with mass m travelling at some velocity v. Now remember from a previous episode, velocity is just a vector form of speed. It's just speed with a direction. And kinetic energy has the unit joules. All energies use the unit joules. It's just a standard SI unit, which again we've covered in a previous episode. The translational kinetic energy is just the effect of a body with mass m travelling at some velocity v. Okay, so up here we have the equation for kinetic energy. Sometimes it's given this symbol, as in energy kinetic. I personally prefer this notation, which literally means kinetic energy. But quite a lot of the time, because kinetic energy can be used in thermodynamics where K has a different meaning, we tend to use this version more often than not in proper notation. But in my notes I use KE, and it is the mass times the velocity squared times a half. These dots here is what we tend to use for multiplication. X's are fine at lower levels of maths, but X's also mean a cross product in terms of vectors. Kinetic energy is very similar to momentum in terms of it's a mass and velocity product. However, kinetic energy is a scalar quantity. That means all it has is a magnitude. So you don't get negative kinetic energies. Why is that the case? Let's have a look. So let's break down what's on the board. We know that the velocity v is a vector quantity. We know that the kinetic energy is equal to a half mv squared. We know this is a scalar quantity. Why is it a scalar quantity? V squared is the same as the dot product between two vector v's. Right? These are the same vector v's. They're exactly the same. They have the same magnitude and the same direction. So, what is a dot product? Dot product is the multiplication of the magnitude of both vectors, in this case they're both the same, times cos, which is a trigonometric function, of the angle between them. Now, because they're both the same, they both point the same direction, they both have the same magnitude, this angle here, this theta angle, is 0. Cos of theta equals 1, so all we have are the magnitudes of the two vectors times each other, which is why we get v squared. Now the magnitude of a vector is just a number, it's just a size. So a magnitude times a magnitude is just going to be a scalar quantity, which is why kinetic energy is just a scalar quantity. Okay, and last little one guys, the kinetic energy here, which we know is in joules, is given by a half, which has no units, it's just a number, mass, which has units kilograms, and the square of a velocity. Now a velocity has units meters per second. It's calculated by the distance over time, so it's meters over seconds, so meters per second, which we can write as -1. But then because it's squared, we get kilograms meters squared per second, or per second squared. There's the actual breakdown of what the joule unit is, but like I said earlier, we give energy as the joule unit. It's nice and easy to work with then, and anytime you see a joule, you know it's an energy. Alright guys, so this has been my take on kinetic energy. I hope I broke it down simple enough. We'll be carrying on with the rest of the energy series next few episodes. It won't take too long to get through. And yeah, you can follow me on Facebook at Physics Explained. You can also find me on Twitter at physics_explain. go check out the website www.physicsexplained.co.uk, or click follow or subscribe depending on whether you're watching this on Facebook or on YouTube.